Okay, so here is the question. Research examining the effects of preschool childcare has found that children who spent time in big dog daycare, especially high quality daycare, perform better on math and language tests than children who stay home with their mothers. In a typical study, a researcher obtains a sample of n equals 11 children who attended daycare before starting school. The children who attended daycare are given a standardized math test for which the population mean is 45. The scores for the sample are as follows. So again, this is my data set, and so it doesn't accurately represent your homework. I've changed the numbers around, so please look at the homework assignment and do that. And this is just a slight change from your homework assignment. All right, so what I'm going to do in order to get this start this up is by putting this into SPSS, and I'm going to just plug in all these numbers here. All right, so what I'm going to do is a little bit later I'm going to make this calculation because we're going to need this in order to get our t value or t statistic. That's what we're going to do in order to calculate our t statistic as well as our confidence interval. All right, so using a two-tailed test with alpha 0.05, find your critical t and plot on a distribution below. So the way that we're going to do this is we are looking at this. So we have our degrees of freedom equals to n minus 1. In this case, we have a sample size of 11. So what we're going to be doing is doing 11 minus 1, which will give us 10. And so we're going to go into a t statistic table, or a t table I should say, and find this t critical, because the t critical are the regions where you have the set point of if it's left of this, here's the critical region for statistical significance. If it's right of this, here's the critical region for statistical significance. And we have our alpha set at 0.05, and we're going to be dividing this 0.05 by 2. And that's what we'll do at the z table, with the z table I should say. And let me go ahead and pull that up. It's right here, our handy dandy z table, or t table, not z table, but t table. All right. So now let's see if I can minimize this just a little bit. All right, it's not going to work with me. All right, so in this case, we'll just move this to the side just a little bit. Now, what we're looking for is first we want to go in the vertical area right here to degrees of freedom. T-table, degrees of freedom, we have 1, 2. We want to get to 10 degrees of freedom. That's where we got our calculation from. So we're at 10 degrees of freedom here. And with this 10 degrees of freedom, we're going to go into where we see the alpha 0.05 intersects with this. Are we using a one-tailed or a two-tailed? In this case, we're using a two-tailed test. So we're going to see where the intersection of the two-tailed test is with this degrees of freedom. So this is alpha 1, alpha 0.5, 0.4, all the way down to 0.05. So here we are. We're at 0.05 alpha for a two-tailed test. And then now we just go down here and we see where the intersection is. The intersection is right here at 2.228. So that is going to be our T critical values, 2.228 and negative 2.228. So we have positive and negative, and if our T statistic crosses this area to the left, then we can reject the null hypothesis, or if it crosses it to the right, we can reject the null hypothesis. So either way, we can reject the null hypothesis. And I just did this right here in this example, but I illustrated this step by step by showing you. All right, so here's what we got here. We have our T statistic that we're calculating, and we're using this formula right here. We need to calculate our mean or sample mean and subtract it from our population mean. Our population mean in this example is 45. That is our population mean, because remember, from this example, we go right up to here. It gives us our population mean of 45 right here. So that is our population mean. But now we need to go into SPSS and calculate the sample mean. And you can do it either through descriptives or frequencies. I'm going to use descriptives. And I'm just going to put in this variable in here and then just go into options and mean and standard deviation in order to get that calculation. And as we see here, our sample mean is 54.45. And I think I'm going to round this to, because we can round this up to 5 and then round this up to 6. I'm going to round this up to 54.46. So this is 54.46 minus the population mean. So we have this information here, but look, we need to get this standard error right here. And the way we need to do that is by getting the standard deviation. So I need to calculate that in order to get the T statistic. So let's go ahead and do that. Here is our standard deviation, 4.22761 divided by our sample size. So we have 11 participants, and that's the square root of that. And then if I was to use a calculator, so if I use a calculator, this is going to come out to be a value of approximately 1.27. And so now I have this value. I'm going to put 1.27 here. And then I'm going to subtract it from, or I'm going to divide it. That's going to be in the denominator. I'm going to subtract this first and then divide it by 1.27. All right, so we have 54.46 minus 45. And that's going to give a 9.46. And I'm going to divide that by 1.27. And that gives us a T statistic of 7.44. Right, so that, what does that tell us about this? Well, it's going to be, I'm just going to write a big equal sign here and 7.45 to round up. It's going to be like way over here somewhere. That's where the T statistic is, right here. So there's definitely a significant difference between these groups. So we calculated that, and we know that it's past this critical region, or this T critical value, into the critical region, and it's at 7.45. That's the T statistic. Now, moving on, let's go on to the next part of this question. So please write this in like the critical T critical values, and then locate where your t-statistic is, and maybe just put like a little dot in the value of your t-statistic. Now you want to compute the confidence intervals, and that's going to be just following this formula right here. You have your t critical of 2.228 plus or minus, and you have your mean at 54.46. So what we're going to do here is 54.46. That should be a 4 plus 2.28, or that should be 228. If I can write this, it's really hard to use a mouse to write this sometimes. Okay, and then our standard error right here, or estimated standard error, which we got from here, 1.27. So it's going to be times 1.27. And then you would do the same thing and find the lower limits of the confidence interval. So this is the upper, and here is the lower. And then that just would be minus 2.228 times 1.27. And I'm just going to exaggerate the 7 by having it look that way. All right, so that's how to get those answers. Just put that in your calculator and indicate whether it's a lower and upper limit. The other thing we're going to do is, well, I did that right there. So it's good to write it down as well, but I have it in a PPT slide. And you would write it this way. So you have a big C and a big I and in these brackets. Here's the lower limit right here, and here's the upper limit. And there's a comma that separates the two. Cohen's d. We have all the information here. We just plug this into this formula, and you just write it out, the 54.46 minus 45 divided by the standard deviation, which in this case, the standard deviation is 4.2276. And so I'm going to go ahead and do this calculation just to see what it looks like. Okay, so I got an effect size of 2.24 approximately, which is a very large effect size. Yeah, so you're not going to get very large effect size, but definitely indicate how large your effect size is if it's way over 0.8, then it's very large. In this case, we do have a very large effect size. And it's just good practice just to see if you are integrating these concepts. You're able to sort of like explain them to me and other people in the future. Do you have a small, medium, or large effect size? So not only give the hand calculation for these, but also how large is your effect size. Other than that, let me see something about the assignment. Yeah, so one last thing is you're supposed to calculate a one sample t-test in SPSS. You would go into Analyze and then Compare Means, because that's what you're doing with a one sample t-test. Go to one sample t-test, and this is our variable with all our values right here. And we're just going to move that over, and our test value is your population mean. In this case, your population mean is 45. And then you press OK. And what we should see is that, well, we have a couple of things we see here. It gives us our t-statistic, which we calculated, our degrees of freedom, 10. And here is population mean, lower and upper limits of our confidence interval, and as well as I think the effect size. If I look at this correctly, the effect size is 4.22. Maybe it's the point estimate. I think this is it right here. So thank you so much for listening. I'll talk to you soon, and see you very, very soon.